Students, welcome to my YouTube channel. We are going to do quiz number 10 today. It will contain questions from the chapters of MET, NAV, REX and Tech. This will boost your preparation for airline exams since it contains questions from various different topics combined in one question paper. So let's start with today's question 1. Question 1 is, there are two locations which have the same atmospheric pressure and temperature, but but place A, location A has dry air and location number B has humid air. So depending on these two locations, considering these two locations, what will be the performance of aircraft? So let's check the basics. This is your place A, this is your place B. At place A we have dry air, at place B we have humid air. Now density of atmosphere depends on three factors: atmospheric pressure, temperature and dryness of air or humidity in air. Now in the question it's given that temperature and pressure are constant. Okay, so let's ignore that. Let's focus our attention on dry and humidity. So what happens when the air is dry? The density of air increases. When the air becomes humid, the density of air decreases in value. Okay, so that's why when air is dry, we have more air density. When we have more density of air in the atmosphere, the air will be thick. As a result, the air flowing through the engines will be helping in efficient combustion of fuel, etc. Therefore, we have better performance of aircraft. Contrary to that, when air is humid, we have density of air which is little. And as a result, when density of air is very less compared to the density of air in dry conditions, the air is thin in size and therefore it will result in inefficient fuel combustion, improper cooling or insufficient cooling of engines. As a result, the performance of aircraft decreases. Okay. Now, when we have greater density of air, we can also interpret that or express that as flying at low density altitude. Less density of air means we are flying at high density altitude. Okay, so the correct option will be what? The performance of aircraft will be better at dry location, that is at location A. Let's go to next question. Atmospheric density reduces at what rate? Now here in front of you is a ISA table in which you have atmospheric pressure, density given to you and the rate at which pressure and density changes. So you have to remember that for pressure, at lower levels of the atmosphere, that is at mean sea level, atmospheric pressure changes by 1 millibar every 27 feet or every 30 feet approximately. But when you go to higher and higher levels, the rate at which atmospheric pressure changes becomes very slow. It becomes slower and slower. That means at mean sea level, if atmospheric pressure is decreasing at the rate of 1 millibar for 30 feet, the same 1 millibar decrease in pressure will happen at a height change of 100 feet at 38,000 feet, okay, approximately. So that means if atmospheric pressure requires 30 feet to bring a change of 1 millibar, at higher levels in the atmosphere to bring the same change of 1 millibar, you will require 100 feet. Okay, that means at higher levels the pressure drops at a very slower rate. Okay, the same logic applies to density. At lower levels, the density of air starts decreasing at a rapid rate, but as you go higher and higher up in the atmosphere, the rate at which density decreases becomes slower and slower. So the correct option will be option number delta. Atmospheric air density reduces at a rapid rate initially, but as altitude increases, the rate becomes at a slow, that is at a reducing rate as altitude is gained. Question 3. In different air masses which have same pressure but lowest temperature, what will be the density of air? Now, like I said before, the density of air depends on three factors: air pressure, air temperature, and dryness or humidity in air. Now, in this question, we are concerned about temperature of air. Now, remember, whenever temperature in the atmosphere is warmer than ISA temperature, we have density of air which will be much lower. Okay, when temperatures go below standard ISA atmospheric temperature conditions, that is when current ambient temperature is colder than ISA, the density of air will be much higher. Okay, so remember that. So in this case, there are two different air masses, one air and one of them has lowest temperature or lower temperature compared to the other. So the air mass which has lower temperature will have density of air which is higher. So option A will be the correct option. Low temperatures means high density. Warm temperatures means low density. Remember that. Next, question number 4. If heated air is confined in the container and is unable to expand, what will happen to its pressure? Now, when in a closed container you heat air, the molecules of the air will gain kinetic energy and will start moving rapidly here and there. In so doing, they will exert pressure on the walls of the container and the container will expand in size. Okay, so in such a case, pressure will increase. But in this question, they have specifically mentioned that the container is unable to expand, which means the atmospheric pressure in the container is remaining the same. The pressure in the container, even after heating, it should increase. But since the container is unable to expand, the pressure in the container is remain the same. Okay, has remained the same. Next is question number 5. Which of the following statements is true with respect to true airspeed? With respect to true airspeed. Now, what is true airspeed of aircraft? Which of the following statements is true with respect to true airspeed? True airspeed of aircraft is actual speed of aeroplane relative to air. Yes, that is correct. True airspeed of aircraft is the actual speed of aircraft in relation to the air. Next, true airspeed of aircraft usually exceeds indicated airspeed. Now, all your pressure instruments, now let's talk about airspeed indicator, is designed to work at ISA atmospheric conditions. Is designed to work at ISA atmospheric conditions, right? So, but every day we don't have ISA conditions. Okay, we have non-ISA conditions. Some days are warmer than ISA, other days are colder than ISA. In such manner, we fly on non-ISA condition days. So, in such on such days, the airspeed indicated by our airspeed indicator is called indicated airspeed. Okay, when you fly on ISA day, on an ISA day, the indicated airspeed will be equal to your true airspeed. Only in those ISA atmospheric conditions, the indicated airspeed, the speed indicated by your aircraft instrument, that is your airspeed indicator, will be equivalent to your true airspeed. In other cases, like non-ISA atmospheric conditions, the indicated airspeed of your aircraft will not be equal to your true airspeed of aircraft. It will be only your indicated airspeed, nothing but dynamic pressure felt at pitot tube converted into corresponding indicated airspeed. So what is true airspeed? In such cases, true airspeed will be derived from indicated airspeed, then calibrated airspeed, then equivalent airspeed, and later after that you get your true airspeed of your aircraft. Now what happens? Indicated airspeed is the result of the pressure felt at pitot tube, which is a combination. Pitot pressure is nothing but your dynamic pressure and static pressure. So at mean sea level, the pressure is maximum. As you go or fly away from mean sea level to higher and higher altitudes, the pressure or atmospheric pressure goes on decreasing. This pressure, as it goes on decreasing, so the pressure that will be felt or sensed or registered at the pitot tube will be much lesser than the pressure existing at mean sea level. As a result, if pressure registered at pitot tube is less than before, the equivalent indicated airspeed will also be much less. For example, if you are flying at mean sea level at a true airspeed of at an indicated airspeed of let's say 100 knots and true airspeed of let's say true airspeed of 150 knots, indicated airspeed 100 knots, true airspeed 150 knots. When you go to a higher altitude, let's say 10,000 feet, you will be flying at same true airspeed of let's say 150 knots like before at mean sea level, but the indicated airspeed, the airspeed indicated by your instrument will be let's say 50 knots, 45 knots. So automatically the speed value indicated by the instrument will decrease. 100 knots indicated airspeed will be equivalent to 40 knots at that 10,000 feet altitude. Whereas you are flying, while you are still flying at the same true airspeed, 100 knots at mean sea level, the same true airspeed of 100 knots at 10,000 feet. So what has changed? The value of indicated airspeed has become 100, has become 45 at 10,000 feet from 100 at mean sea level. Okay, so as you go to higher and higher altitudes, the separation between your indicated airspeed and true airspeed goes on increasing. True airspeed, so therefore, what will happen? You are flying at true airspeed of 100 knots, indicated airspeed you are getting, correction, true airspeed of 150 knots, the indicated airspeed you are getting of, uh, so true airspeed 150 and indicated airspeed 100 knots. At 10,000 feet, your true airspeed is 150, your indicated airspeed is 50 knots. Because at higher levels, atmospheric pressure decreases in value. Now to make this indicated airspeed from 50 back to 100, what will you have to do? You will have to fly an aeroplane at much faster true airspeed. So you will have to fly at true airspeed of, let's say, 200 knots now. So when you increase the true airspeed of your aircraft, that means you add power and increase the forward motion of your aircraft. And when true airspeed, let's say, becomes 200 knots or something like that, the indicated airspeed will increase from 50 knots to 100 knots. So that is what happens when you go to higher altitudes. The true airspeed of aircraft increases. Why it increases? Because atmospheric pressure at high altitudes is less. So to generate extra pressure artificially, we will have to fly a aircraft with much larger force at much higher airspeed, so that those higher airspeeds will generate a huge or a huge more or larger impact pressure at the pitot tube. And so this will be compensating the lower static atmospheric pressure surrounding your aircraft. Okay, so to compensate for lower atmospheric pressures, you will have to fly your aircraft at much faster through airspeed, so that the impact pressure felt at the tube will be much more, and therefore the indicated airspeed will be much more than the 50 knots here. Okay, so this is what happens. Usually, true airspeed of aircraft will always exceed your indicated airspeed. Why? Because your aircrafts are designed to fly at higher altitudes where fuel combustion is efficient, and you tend to reach your destination faster at those when you fly at higher altitudes, right? So, and at those altitudes, you will definitely get indicated airspeed which is much lesser than the true airspeed because pressure decreases at higher altitudes. So, option B is also correct. Option C says true airspeed is important for navigation purpose. All your flight planning includes your true airspeed of aircraft, which you get from your pilot's operating handbook, depending on altitude you're flying, etc. Now, from true airspeed, when you add a wind component to it or subtract wind component from it, you get ground speed. When you have ground speed, you can determine estimated time of arrival at your destination or the next checkpoint or the next reporting point. Okay, so that's why true airspeed is also important for your flight planning purposes. So all the options of above are correct. Therefore, you will select option delta in exam, which states that none of the above options are wrong. Okay. Question 6. The airspeed indicator is what? So airspeed indicator is a pressure gauge. It's not a temperature gauge, nor a vacuum or gyroscopic gauge. So it's a pressure instrument. You have flown 52 miles and are 6 miles deviated from the track. You have 118 miles yet to fly. Remaining distance is 118. To converge on your destination. So the question asks you that you have to get back to your destination directly and not converge or join the track to your destination. Okay, so there are two methods. There is a double track error method. Using the double track error method, you will come back to your track and then go to your destination. Second method is track error and closing angle, in which you will fly directly to your destination. So what is the total correction angle required? So let's draw this. There is a departure airport A. There is a destination airport B. This is your track A to B, original track. But you have deviated from A, your track, and you are currently at position C. Okay. You have flown a distance of 52 miles from A and you are 6 miles deviated from the track. Okay. So let's first find track error. Let's find track error. So track error is how much? Track error is equal to distance of track, distance gone into 60. So distance of track is 6, distance gone is 52 into 60. This will give you a value of 7 degrees, approximately 7 degrees. So this is your track AB. AC is your track made good and the track error is 7 degree. Now your plane is at point C. Your plane is at point C. Okay, and you're deviated from that track and you're going away from your original track in this direction. So your first priority will be to stop that deviation to arrest that motion, forward motion of aircraft. When you do that, you will be flying parallel to track. You will be flying parallel to track AB. Okay. So what will you do? First, to stop that deviation, you will have to turn right hand side. By what angle? By this 7 degree angle. Why 7 degree? Because this two angles make corresponding angles, are corresponding angles, and corresponding angles are equal. Now your solution doesn't end here. You will have to make another right turn. You will have to make another right turn so as to come back to location Bravo. Okay. So how much is that? How much angular turn will be that? So for that, now you will have to focus your attention on this side of the triangle. What is the distance remaining to go to your destination? It is 118. So let's find closing angle. This angle will be called closing angle, which will close the error that you have made. So distance of track divided by distance remaining. Distance of track is 6. Distance remaining is 118 into 60. So this will be equal to 3 degrees. So angle is 3 degrees. If this angle is 3 degree, this angle will also be equal to 3 degree because alternate angles because alternate angles are equal. Alternate angles are equal. Remember that. So now what is the total correction that you are making ultimately? You are making a total correction of 7 plus 3 which is equal to 10 degree. And on what side? On right hand side. 10 degree correction to the right hand side. So this is how you do the sum. Option is Charlie, 10 degree. Let's go to question 8. When the CDI needle is centered during an airborne VOR check, the OBS should read what? So there are two types of check. You can check your VOR on the ground. When you check the VOR on the ground, the accuracy limit should be 4 degree plus minus 4 degree. When you do a VOR check in air, the accuracy limit is 6 degree. So the correct option will be Bravo because this is an airborne VOR check. Option Charlie says OBS should show 0 degree 2 indication. Always remember whenever you are checking your VOR facility using a VOR test facility at the airport, irrespective of your irrespective of your aircraft position, it should show it should show 360 degree or 000 degree from indication, or it should show 180 degree to indication. 180 degree to indication. So you may be to the north of VOR, to the east of VOR, west, south, southeast, southwest, doesn't matter. Irrespective of your position, the VOT facility must always show either of this 360 degree from or 180 degree to. Even if you are not to the north of the VOR, you are to the east of VOR, it should show this values. Okay. So this is wrong. It says 0 degree 2. It should show 1802. Okay. So C and A are thus wrong. So this ends our lecture today. I hope you have understood these 8 questions. You were able to answer all the 8 questions properly, and I hope you have understood the explanations, the conceptual understanding I have given to you. You learned something new today. So keep learning. All the best. And if you have liked this video, hit the like button, subscribe to this channel if you haven't, and share this video with all your colleagues and friends. Thank you for your time. See you next time.